Hi guys, I've been on vacation for a bit, such is the life of a sailor. But now it's time to get back to work, and of course record some videos. Today I'll show you how to repair a mechanical fuel injector from the main engine, specifically how to replace the nozzle. The design of a mechanical fuel injector in a marine diesel engine is simple as possible. In most cases, failures are caused by natural wear of the nozzle, as it processes an enormous volume of fuel over time. In my case, for example, a 3000 kilowatt diesel engine can consume up to 10 tons of fuel per day when running at full speed. So based on my observations, the nozzle performance noticeably drops after approximately 7000 operating hours. And I invite you to watch the process of the replacement. This surface I am showing right now needs to be in perfect condition, free from scratches or corrosion, because the nozzle presses against it directly without any seals, just metal to metal, and this connection must be super leak tight. By the way, the liquid in the green canister is pure diesel fuel. We always perform work on fuel equipment using this. Here are the internal components of the injector: the pressure adjustment screw, essentially the spring compression screw, the spring itself, and the plunger that applies pressure to the nozzle needle. In our case, the nozzle mating surface looks good, with no significant damage. We'll skip the lapping process. Instead, I'll slightly refresh it using the finest lapping paste and a regular cotton cloth. Since this is a repetitive process that takes about 5-7 minutes, we'll skip it ahead. In the meantime, let me explain how everything works together. The fuel enters the injector through this side hole and travels through the internal passage to the nozzle, passing right through the surface I'm currently cleaning. Next, the fuel flows through the small passage in the nozzle body and reaches the conical seat of the needle. The nozzle needle and seat form a precision pair with an ultra-high level of surface finish. When closed, they must create a perfect seal, preventing even a single drop of fuel from leaking. The spring is essential for closing, as it applies a constant force on the needle from above to ensure it seals properly. When the fuel pressure at the injector inlet rises above 450 bars in our case, the spring force is no longer enough to keep the needle pressed against the seat. As a result, the needle lifts slightly, allowing the fuel to flow towards the outlet holes. And in this very moment, the fuel is sprayed into the cylinder. Once the injection cycle is complete, the pressure at the injector inlet drops, and the needle tightly closes the nozzle holes again. Alright, everything is ready for assembly. We'll rinse off any leftover paste, blow everything out with air, and then begin the assembly. It's the same process, just in reverse order. By the way, we apply anti-frictional paste to the only O-ring and all threaded connections. I haven't checked the composition, but it looks like molybdenum or graphite. This not only makes future disassembly easier during repairs, but it also helps tightening the main nozzle connection to the correct torque. Now, let's install the nozzle itself. It's crucial to ensure that no dirt has entered the nozzle and that the needle moves smoothly, falling into the body under its own weight. We also need to make sure that all mating surfaces are clean. And now we're ready for the final assembly stage, and for this we'll need a very large wrench. This tool, 1.5 meter long, can tighten the threaded connection to impressive 800 Newton meters. In my case, it's set to click when it reaches 680 Newton meters, which is the required torque according to the manual. Now we connect the fuel supply fitting, and the injector is ready to be installed on the test bench. It operates in a simple manner. A fuel reservoir filled with diesel, a hand pump with a long lever to generate the required pressure, and the pressure gauge that allows us to adjust the injector opening pressure. Next, you'll see firsthand how the fuel is atomized inside the engine cylinder. I'll gradually compress the nozzle spring using the adjustment bolt, so you can observe how the fuel spray quality depends on the nozzle's opening pressure. Just to remind you, the working pressure for this model is 450 bars. And this is how a properly functioning injector should perform with the correct pressure setting. I think the difference is quite obvious, and for clarity, I'll place two frames side by side. By the way, worn injectors tend to spill fuel rather than atomize, even when the pressure is set correctly, kind of like what we observed at 100 bars in our case. And that's it. The injector is ready to be installed on the engine. Now let's prepare it for storage. We'll release the tension on the adjustment screen. Apply some machine oil to critical areas like the nozzle and the fuel inlet surface. Warp it in plastic and place it on the shelf. And that wraps up this video, but I still have to repeat this process 7 more times. Thanks for watching, I hope you found it useful.